Hello and welcome back. This is part 3 of the Inter-VLAN routing. We've done 2 parts so far. We created VLANs. We managed to get communication between the same VLAN across different areas of a building. But now what we need is communication between different VLANs. That's why we need a router or a layer 3 switch. We have a router over here. We have and then a data center across the city somewhere else. And we need to have that communication. So what I'm going to do is, first of all, I want to create a trunk between the switch to the router that carries all the VLANs so that the router will be able to do the communication. So if we get a interface, we already have fast Ethernet 1 all the way to 5 to be a trunk. And if I now configure the first fast interface 0/0, and if I configure that as a trunk, then I will create something called router on a stick, or sub interfaces. So let's go to the router and let's go to its interface. This is from a previous configuration, so the router is named, the interfaces are configured. So if I show you show IP interface brief, you can see the serial link between the two routers is configured, but it is down because there's no cable. What I need is this interface. I will create sub interfaces here. So I would say conft and then go to that interface fast Ethernet 0/0. First thing I have to do is to enable it. So no shutdown. When I do that, I want to create this interface to be a trunk and create sub interfaces. So to do that, let's create sub interfaces and say exit and say interface fast Ethernet 0/0. That was the main interface. But under that, we want to create sub interfaces, and we have VLANs, and it's easy to name the same number. Let's call 10. That's for VLAN 10. .20 for VLAN 20. Whatever you have, maybe that way it's easier to read when you are reading the configurations. So now we have a sub interface under the main interface fast Ethernet 0/0, which is 0/0.10, and then we have to create encapsulation .1q. And then if you put a question mark, it tells you what VLAN you want to carry. So .1q, and then you create the VLAN number. And the VLAN number we're trying to carry is 10. When you do that encapsulation, then we can assign an IP to this sub interface. VLAN 10 was, if we say IP address, was 10.1.1. We give the 1 to the router, and the subnet mask is /24. That way we have now a sub interface with an IP address. So if you go back and say show run, or let's say show IP interface brief, you see now the fast Ethernet, the first one is only status up and there's cable connected, of course, but the sub interface for VLAN 10 is this one. We need VLAN 20 as well. So let's go and configure VLAN 10 sub interface. Conft interface fast Ethernet 0/0, then whatever the VLAN was, and then we call encapsulation .1q, and then you provide the VLAN number. When you do that, then you can give an IP address, and you can say IP address. The VLAN 20 was actually 20.1.1.1, and the subnet mask is /24, so we call it 255.255.0, and you don't need no shut because the main fast Ethernet is actually we enabled it, and these are sub interfaces. So let's exit that and check again what's there. Show IP interface brief, and you can see now two sub interfaces are both up and they are in the router. So what does that mean? This PC here is on VLAN 10. This PC here is VLAN 20. If they want to communicate, they need router, and the router has sub interfaces. The reason we are doing sub interfaces is maybe you have limited interfaces on your router and you want to achieve that routing from a one physical interface. Then you create sub interfaces, and that's enough for small offices. So what we need to do now, the sub interfaces are there, but these PCs do not actually know how to reach the default gateway. So we need to configure a default gateway, and we go to the desktop and IP configuration. Here we provide the sub interface IP, which was 10.1.1.1. That way the PC will be able to do, otherwise it won't know where to forward the traffic. Then we go to this PC again and we provide a default gateway on here as well. and that one is 10.1.1.1. Now we have 2 PCs, and the one over there also needs a default gateway. And now you're sensing that the effort it takes to configure all these things statically. In coming videos, we will configure DHCP, which actually eases the time. And if we provide the IP to here, the default gateway is going to be 20.1.1.1, and this also is from VLAN 20. So if we close this one and provide the default gateway, it is 20.1.1.1. that's the default gateway, and we are done with that PC. Here I have another PC, and the default gateway is missing, and again it's 20.1.1.1. So we have now default gateways configured on all the PCs, and we have the router having the sub interfaces. And then if you go to show IP route, you can see we have connected interfaces. Let me make this one a little bit bigger so it covers. Let's do that. It tells you I can reach 10 and then I can reach 20. Both of them are connected, subnetted. If you see subnetted, and it is the main it shows, but what we have is this subnet 20.1.1.1. the main subnet is class A, so it would be like that, but we have a subnetted, we're using that interface. But anyway, we can reach our interfaces. They are showing as connected interfaces, and also the interfaces are all up, they are connected. If you can see, the first one is unassigned, we're using it as the main, and here sub interfaces. So let's do some tests. Let's start pings from this PC here, pinging a PC over there, and that's 20.1.1.11. let's do that. And if we do that from PC1, we go to command prompt. Previously what we had was let's go to 20.1.1. and let's say 10, the first one. It takes maybe the first packet, you can't get a response, maybe the second one. So there you go, you have the first one missed, and then the remaining 3 completed successfully. If we ping again, it's now in the cache, so we have 4 sent and 4 received. That's successful. And we tried from here to ping to PC1. So let's see how we did that and what was the result. If you see again, that was not communicating. If we ping the same thing, now you see the ping is there. There are different networks, but the router is allowing that to happen. What about if we need to reach the subnet over here? And also, what would happen if we need to assign IP addresses dynamically? So in another video, I'm going to configure the network between our site and the data center, and then manage to access that server over here. Thank you, and see you in the coming video.